Okay, so we are in 2.2 day 1. The first topic I'm going to talk about is the vocabulary word axis of symmetry, which we've already heard this term before. We're just going to go over what the vocabulary term means again. Okay? An axis of symmetry is a line that divides a parabola into mirror images and passes through the vertex. So in this diagram to the right, the red line right here that passes through the vertex is your axis of symmetry. Does everyone see that if I were to fold along that line, how one side of my graph would land directly on top of the other side of the graph? Okay. It divides the graph into two parts that are mirror images of each other. It says because the vertex of your function is hk, the axis of symmetry's equation is going to be the vertical line x equals h. Okay. Basically, if you look at this diagram, does everyone agree that the axis of symmetry runs through the vertex? See how the x value of your vertex here is h? The x value of your vertex is always going to tell you the x value for the axis of symmetry. Okay? Because your axis of symmetry runs through your vertex. Any vertical line always has the form x equals something. Any vertical line has the form x equals. Okay? It's just a matter of saying to yourself, what does x equal? Well, in this case, it's going to be h. It's going to be whatever the x value of your vertex is. So in the first example here, it wants us to graph the function, label the vertex, and the axis of symmetry. Okay, so let's go ahead and get started with that. I'm going to do my xy chart. Okay. And I'm going to write the parent points for a quadratic function. I know that I'm writing the parent points for a quadratic function because I see this squared in my equation. Okay, so I'm going to write the parent points for my function y equals x squared. -2, 4, -1. If I square it would be 1. 0 when I square it is 0. 1 when I square it is 1. And 2 when I square it is 4. Now I'm going to go through each part. I'm going to start with the negative out front. The negative is a vertical reflection in the x-axis. So because it's vertical change, I'm going to change all my y values. It's going to become -4, -1, 0, -1, and -4 when I multiply everything by -1. Okay. Then I move on to the next part. The next part is I see this 2. The 2 indicates a vertical stretch by 2. So because it's vertical, again, I'm going to change all my y values. Okay, so I'm going to vertically stretch all my y values by 2. So now I'll have -8, -2, 0, -2, and -8. Then I move to the inside. The inside here is x plus 3. That's going to be my shift to the left 3. And because it's horizontal movement, it's going to change my x values. So all my x values are going to move left 3 units. If I subtract 3 from -2, that's -5. There we have -4, -3, -2, and -1 when I move everything to the left. And last but not least, I see this +4 on the end. That is my up 4 shift. Anything that moves up is vertical change. Okay, so I'm going to change all my y values if I'm moving my graph up by 4. So I have -4, that'd be 2, 4, 2, and negative 4. Okay, and that's about as hard as it gets with all those transformations. So that gives me my function to graph. I'm going to graph my function with the point negative 5, negative 4. Didn't need to make that point. 1, 2, 3, 4, 5, 1, 2, 3, 4. Negative 4, 2. Negative 3, 4. Negative 2, 2. And negative 1, negative 4. Okay, so there's my graph. It wants me to label my vertex and my axis of symmetry. Okay. I honestly could have told you what my vertex is without even doing the XY chart. Everyone see how this was a left 3, up 4 shift? If I'm going left 3, up 4, just from that alone, I know my vertex is negative 3, 4. But if I want to see it in my XY chart, this is where my vertex used to be, and this is where my vertex is now. See how in my XY chart you can see the point negative 3, 4 as well? Okay. So whatever floats your boat. My axis of symmetry is the line that divides the graph into two parts that are mirror images of each other. So my axis of symmetry, I'll go ahead and graph it in red. It's going to be this line right here. See how it divides the graph into two mirror images? It divides it in half, where they're mirror images of each other. That's what I'm trying to say. Okay. What is the equation of this vertical line? X equals what? Zach? Negative 3. Excellent. I can always use my x value from my vertex to help me with the axis of symmetry, because the axis of symmetry will always run through my vertex. Okay, this is your axis of symmetry. By the way, I always abbreviate axis of symmetry, AOS. So if you ever see AOS, that's what it means. On your homework, too, you'll have to identify whether the vertex is a max or min. I think I make you circle it. I think I have max or min listed, and you have to circle it. It's just going to depend. If a graph is opening up, my vertex is going to be a minimum value. It's the lowest point on the graph. And if my parabola is opening down, then that would make my vertex a maximum value because it's the highest point on the graph. So if you look at this graph over here, is my vertex going to be a maximum or a minimum? Yeah, the vertex is the highest point on the graph in this case. So my vertex is going to be a maximum. So I would circle maximum. Any questions about that? Okay. All right, go ahead and flip your paper over. We've done a lot with the transformation, so I'm not going to spend too much time on vertex form. I'd like to talk a little bit about the core concept box here. In the core concept box, you can see how now we're going to talk about the properties of a graph in ax squared plus bx plus c form. I previewed this a little bit last class. What kind of form is that? Standard form. Okay. Can you tell the vertex using standard form easily? No, you can't clearly see the shifts left, right, or up or down. So it becomes harder to identify what the vertex is. So you have this property down here that the axis of symmetry is going to be this equation, and the vertex is going to be found by using this rule. Now, I am someone that hates it when a teacher just gives me a rule and they're like, okay, use it. I'm like, where did that rule come from? Did you pull it out of a hat? Like, where is that rule coming from? So I'm going to show you how this rule for the vertex is derived. Remember, with vertex form, normally my vertex is h comma k. So I'm going to show you how they get an h value of negative b over 2a and how they're getting this k value, how they're getting this new vertex. I'm just going to show you quickly. I'll never ask you to reproduce this, so I'm going to move through it kind of fast. But I want you to realize that the rule comes naturally from vertex form. Okay, so if I go back here, it says quadratic functions can also be written in standard form. Ax squared plus bx plus c, where a is not 0. You can derive standard form just by expanding vertex form. So I'm going to take vertex form and I'm going to multiply it out, and I'm going to show you what the standard form looks like. Okay, so here's vertex form where the vertex is normally h comma k. Okay. That was really poorly written. Okay, vertex is h comma k. Okay, I'm going to expand this out. So the first thing I'm going to do is I'm going to write x minus h twice so that I can FOIL it out. I do first times first, that's x squared. Outer times outer would be minus hx. Inner times inner is also minus hx. And last times last, negative h times negative h would be a positive h squared. Does everyone see how I FOILed that out using the distributive property? Okay. Before I go any further, I'm going to combine these like terms. If I have 1 minus hx, and I add on another minus hx, how many minus hx's do I have? I have 2 of those minus hx's. Right? So when I combine those like terms, I'm going to get a, this will be x squared minus 2 of those hx's plus h squared plus k. And now that that part is completely expanded, I have to take a and distribute a through to each term inside the parentheses. So I'll end up with ax squared minus 2ahx plus ah squared plus k. Now this looks kind of crazy. I want you to pay close attention to where your x's are though, and we're going to compare it to standard form. Standard form looks like this: ax squared plus bx plus c. That's what standard form looks like. Okay? Now, what is your a value in the expanded version of the vertex form? A is just a. See how the x squareds line up? Okay, so on that first blank where it says a equals, you're going to put a equals a. Okay? Then I need to know, what does b equal? Well, here, see how the x's line up? Everything in front of x is going to be your b. So I'm going to say that b is minus 2ah. And then all the rest of this stuff is going to be your c value. C is ah squared plus k. And I'm going to show you how they got the rule in the core concept. Okay, so this is what I'm going to fill in with the blanks. We got that a equals a. What did we get for b? B was negative 2ah, and c was ah squared plus k. Okay, that's what we just saw. So here's the deal. We've got these two forms. This is my vertex form. And then I have this form, which is standard form. I want you to realize that the A in vertex form is the same as the A in standard form. So what that means is if you have a vertical stretch or shrink in vertex form, or if you have a vertical reflection in vertex form, that A is going to mean the same thing in standard form. Okay? So whatever your A is in standard form, it's going to tell you your stretch or shrink vertically and your reflection vertically, if there is one. Okay? For B, what it wants us to do is it wants us to solve for H. What is so important about H? Why is H important in vertex form? What does H help to tell us?
H is part of the vertex.
H is part of the vertex. You got it. In vertex form, I like knowing H because it helps to tell me the X value of my vertex. Wouldn't it be nice to know what H is in standard form? Okay, so let's figure out what H looks like in standard form. B is negative 2AH. Let's get H by itself. How would I get H by itself? Divide both sides by negative 2A. See how H is negative B over 2A? Wasn't that part of the rule from the core concept? Right, if I go back to this core concept, didn't it say that I get the vertex by using negative B over 2A for the X value? That's where it's coming from, okay? You'll just end up memorizing this, but again, I don't want you to just think I'm pulling it out of thin air, okay? It does come from something. It comes from the vertex form, okay? And if the X value for standard form is negative B over 2A, then what is the equation of my axis of symmetry? X equals negative B over 2A. Remember, the axis of symmetry runs through the vertex. Okay. All right. And then the last part, this part talks about plugging in 0 for X. If I'm plugging in 0 for X, what am I finding? Anytime you plug in 0 for X, you are finding some Y value. What is the significance of that Y value? You plug in 0 for X to find the what? What kind of Y value?
Think back like our original form, right? Anytime we're working with any type of function, if our X value is 0, so again, think back to a graph, if your X value is 0 starting at the origin, what's that Y value going to mean?
Say it loud. It's a y-intercept. Very good. Okay, so what they're saying here is if I take vertex form and I plug in 0 for X, okay, notice that f of 0 is AH squared plus k. That ending C value is going to tell you the y-intercept. Okay, so when you're looking at standard form, this ax squared plus bx plus c, whatever this C value is going to tell you the y-intercept. Okay? Just a nice fact. All right, so like I said, I just want you to understand where this is coming from. I'm not going to ask you to reproduce this. I'm going to ask you to memorize it. Okay? But hopefully you understand that it's everything from standard form is just derived from vertex form. That's the big shebang. Okay? So in this example, I'm giving you a function that's in standard form. Does everyone agree? It's got two x values, right? We've got x squared and x. So that's how I know it's in standard form. Okay. And I can't easily see the shifts. So I run into a problem. When I'm working with standard form, this is the process that I go through. I first find the vertex. I then graph the axis of symmetry. The third thing I do is I find the y-intercept. And then the last thing I do is I mirror the y-intercept. Okay, that's the process we're going to go through. Okay. So the first thing I'm doing is finding the vertex. The rule for vertex is stated in the core concept. It's negative b over 2a, f of negative b over 2a. Don't worry about that y value. This looks scary, but it's not bad. Okay, I'm just going to focus on this part first. Okay, I'm finding the x value of my vertex. Three is your a value, negative 6 is your b value, plus 1 is your c value. Okay. And I'm plugging it in to this. So I'm going to have x equals negative b. What was my b value? Oh, good. Yes, thank you, Ethan. B is negative 6. Okay, so I'm plugging in negative 6 over 2a. 2a. What was my a value? Tyler, what's my a value? 3. Yeah, good. Okay, so now I'm going to simplify that. X equals, that would give me 6 over 6, okay, which is 1. Okay, and now think back to when we did system of equations. We get a variable. We get that x is 1. Are we done? No. How am I going to get y? Plug it in. You got it, right? This all goes back to systems. Once we get an x value, all this scary notation means is to take negative b over 2a and plug it back into our function. That's all it means. Okay, so it seems scary, but it's not too bad. We got that x was 1. So I'm just going to plug 1 back into my function. What was my function? Yeah, 3. Oops, whoa. Yeah, I might need to read it for me because, okay. 3, 1 squared, okay?
Minus 6x.
Minus 6x. And then plus 1 on the end? Okay, so we would have, remember order of operations, we're always going to do the squared first and then multiply by the leading coefficient. So we'd have 1 times 3, which is 3, minus 6 plus 1. So we get that f of 1 is negative 3 plus 1, negative 2. Is that right? Did I screw that up anywhere? No. Okay, so y is negative 2. We plugged in x, and we got y. So if I'm writing my vertex, it's going to be, I think froze. Of course. It does. It's every day, and I think it's at like the same amount of time. Let's see. Okay, so go ahead and write your vertex. 1, negative 2. And go ahead and graph the vertex. There we go. Okay, we're back in business. All right, so we get that the vertex is 1, negative 2. 1, negative 2. Looks like this. This first step is done. What's my next step? Graph the axis of symmetry. Doesn't the axis of symmetry just go right through the vertex? Okay, so my axis of symmetry is going to look like this. What is the line of the axis of symmetry? X equals what? 1. If it goes right to the vertex, you can just use the x value of your vertex to know what the equation of the axis of symmetry is. Okay, so I did that. Done. Now I need the y-intercept. How do I find the y-intercept? Plug in 0 for x, solve for y. Okay, so I'm going to plug in 0 for x up here. Y-intercept? Someone read me that again. 3 times x, right? 0 squared minus 6. Okay? Plus 1. Look what happened. 0, 0, 1. Okay, so my y-intercept 0, 1. Right? I just get 1. 0, 1 is my y-intercept. Does everyone agree that this should be a mirror image on both sides of the axis of symmetry? So as long as I know my y-intercept, all I have to do is reflect it over that axis of symmetry, and that'll give me an idea about what the width of my graph is. Okay, so once I get the y-intercept, that's great, because now I can just go like this. Shink. Done. Okay? What can you do to get more points to graph? Got to do with your calculator. Where could you go on your calculator to get more points? The table. Right? So don't forget that. If you ever need more points to graph, just put this into your y equals on your graphing calculator and go to the table on your calculator. You can get an infinite amount of points to graph using your table. Okay? So do not forget that. If you're in a pickle and you don't know how to graph it, go to your table. Okay? That's where we're going to stop.